Detailed overview of waste and its management. Introduction. Waste management encompasses the collection, transportation, treatment, recycling, and disposal of waste material generating by human activities. Its primary goal is to minimize the adverse effects of waste to human health, the environment, and aesthetic while promoting resource conservation and sustainability. Globally, waste generation is increasing due to population growth, urbanization, and industrialization, with an estimated 11.2 billion tons of solid waste collected annually, contributing to environmental pollution and climate change. UNEP 2022. These documents provide a detailed exploration of waste types, management method, challenge, and strategies for effective waste management. Types of waste. Waste can be categorized by its source, composition, and biodegradability, is requiring specific handling and disposal methods. Below are the main types. Municipal solid waste. Municipal solid waste. Waste from households, commercial establishment, and institutions, including food scraps, paper, plastic, glass, and textile. In 2018, the US generated 292.2 million tons of MSW with 50% landfills, 32.1% recycled or compost, and 11.8% combusted with energy recovery. Hazardous waste. Material with properties like ignitability, corrosivity, reactivity, or toxicity, such as chemicals, batteries, and medical waste. This require special handling to prevent harms to health and the environment. Organic waste. Biodegradable material like food scraps, yard trimming, and paper that can be composted into nutrient rich soil. Liquid waste. Waste water, oils, and chemicals from households, industries, and medical facilities that can contaminate water source if not treated properly. Electronic waste. Discarded electronic devices like computers, phones, and appliances containing toxic substance, lead, mercury, and valuable recyclable materials, gold, copper, construction and demolition waste. Debris from construction sites, including bricks, wood, and cement, accounting for about 20% of solid waste in the US. Industrial waste. Byproducts from manufacturing processes, such as toxic metals and chemicals requiring specialized treatment. Biomedical waste. Waste from healthcare facilities, including syringe, bandage, and expired medicines posing infections risk. Waste management hierarchy. The waste management hierarchy priorities method based on environmental sustainability from most to least preferred. Prevention reduction, minimizing waste generation through sustainable design, reduce packaging and conscious consumption. For example, materials passport in construction, optimize material use to prevent waste, reuse, extending the life products by repairing, refurbishing, or donating items. For instance, reusing construction materials, reduce raw materials extraction, recycling, converting waste into new products, saving resource and energy recycling. 1 ton of paper saves 17 trees and 50% of water. Recovery, extracting energy or materials from waste such as through waste to energy, incineration or landfills gas recovery. Disposal, landfilling or incineration without energy recovery, the least preferred option due to environmental impacts like methane emissions and soil contamination. Waste management method, effective waste management employs various methods tailored to waste types and local regulations. Landfills, designated sites for waste disposal equipped with linears to prevent groundwater contamination. However, landfills produce methane, a potent greenhouse gas, and occupy valuable land. In India, only 47 million of 62 million tons of annual solid waste are collected, with much ending up in untreated landfills. Recycling, processing materials like paper, glass, plastics, and metals into new products. Recycling reduces greenhouse gas emissions and conserves resource but requires efficient sorting and infrastructure. Composting, decomposing organic waste into nutrient rich soil conditioner, reducing landfill burden and enriching soil. Composting is viable for households and municipalities. Incineration, waste to energy. Incineration, waste to energy. Burning waste at high temperature to reduce volume and regenerate energy. While effective for hazardous waste, incineration can emit pollutants like carbon dioxide and nitrogen oxide. Anaerobic digestion, breaking down organic waste in oxygen free environments to produce biogas and fertilizer. This method supports circular economy goal. Challenge in waste management. Despite advancements, waste management faces significant challenges globally. Rapid urbanization. Urban areas generate vast waste volumes, overwhelming infrastructure. India's urban population of 377 million produces 62 million tons of solid waste annually, with only 30% properly sorted. Inadequate infrastructure. Many developing countries lack sufficient collection, sorting, and treatment facilities. Globally, about 25% of municipal solid waste is uncollected, and another 25% is mismanaged, often burned openly. E-waste growth. E-waste containing toxic and valuable materials is the fastest growing waste streams, requiring specialized handling. Cost constraints. Effective waste management is expensive, comprising 20 to 50% of municipal budget. Without adequate funding, system remain inefficient. Lack of public awareness, insufficient education on waste segregation and recycling hinders participation. Community involvement in critical for success. Informal sector challenges. In many regions, informal waste pickers operate without regulation, facing health risk and low wages. Integrating formal and informal sectors is a key challenge. Strategies for effective waste management. To address this challenge, the following strategies are recommended. Policy and regulation. Enforce laws like the US Resource Conservation and Recovery Acts (RCRA) or the EU's 2021 single-use plastic ban to promote sustainable practices. Circular economy models promote waste prevention, reuse and recycling to decouple waste generation from economic growth. A circular economy could yield a net gain of 108.5 billion US dollar annually by 2050. Technology integration. Use IoT, AI and blockchain for efficient waste tracking, collection and sorting. For example, RFID enable monitoring, improve waste management in India. Public awareness campaign. Educate communities on the 4R principle: reduce, reuse, recycle, recover to enhance participation. Re-centralized system. Implement local composting and biomethanation to reduce landfill reliance. Public private partnerships. Foster collaboration to found and operate common waste treatment facilities, ensuring proper handling of biomedical and hazardous waste. Waste management and climate change. Poor waste management contributes to climate change through methane emissions from landfills. 15.5% of US methane emissions in 2021 and greenhouse gases from incineration EPA 2025. Effective strategies like recycling, composting and waste to energy reduce emissions and conserve resource. For instance, recycling reduce the need for raw material extraction, lowering carbon footprints. UNEP 2022. Additionally, or organic waste management through composting and anaerobic digestion mitigates methane production, aligning with global climate goals. Conclusion. Waste management is critical for environmental protection, public health and resource conservation, with municipal solid waste projected to reach 3.8 billion tons by 2050. Urgent action is needed to implement sustainable practices by prioritizing the waste management hierarchy, leveraging technology, and fostering global collaboration. Societies can transition to a circular economy, reducing waste, environmental, and climatic impact while ensuring a sustainable future.